Now let's solve the example. First, there is root 2 is a irrational number. Prove that root 2 is irrational number. Prove that root 2 is irrational number. Proof of root 2, root 3 and root 5 are almost similar. The pattern is almost the same, only the number will change. Instead of 2 it will be 3, or instead of 3 it will be 5. Only the number will change. The rest, the process will remain the same. So it will begin with the same. If possible, let root 2 be a rational number in the simplest form. So root 2 equal to a divided by b. B does not equal to 0. Simplest form means only 1 is the common factor. So now squaring both sides. First write it as it is, root 2 equal to a divided. Now main target to remove the square root. So take the square both side, squaring both side. So it gives square root, that is 1 by half. This 2 and this 1 by half will cancel. It will only 2 will remain. So it will be a square divided by b square. Now take b square this side, each divide, it will be multiplied. So 2b square equal to a square. Now see, this is divisible by 2, here 2 is there, so therefore this will be divisible by 2, implies a square is divisible by 2, or you can write 2 divides a square, that is both are correct. A square is divisible by 2, both are correct. Divisible by 2 implies a is divisible by 2. Now we got a is divisible. Now we will check for the b. So give it equation 1. Now a equal to, here because it is, we are going to prove root 2, we are going to prove the root 2, that time you will take a equal to 2c. If we are going to prove there is root 5, that time you are going to take a equal to 5c. If it is a root 3, you are going to take a equal to 3c. Only that is the difference. The rest only instead of 2, if it is the root 3, it will be all 3. If it is the root 5, instead of here 2, all will be 5. So for some integer, let a equal to 2c for some integer c. Now put this in equation 1. Now putting a equal to 2c in equation 1. So it will be 2b square equal to 2, instead of a put 2c whole square. So it will give 2b square equal to 4, because 2 square is 4, c square. This is divisible by 2. So b square is equal to 2c square. This is divisible by 2. Now therefore implies b square is divisible by 2. divisible by 2 implies b is divisible by 2. So we got 2 is the common factor of both. We have considered 1 is the only common factor. So it come to the contradiction. Thus two is common factor of A and B, which is contradiction, which is contradiction. Therefore, root 2 is irrational number. Example number 5. That is example number 5. This is a continuation of the first exercise, because example after 4 we complete. Now example number 5, that is proof that root 3 is an irrational number. Us exactly same. Example 3, that is proof that root 3 is an irrational number. Same, consider it. If possible, let root 3 be rational number in the simplest form. That is root 3 is equal to a divided by b. B does not equal to 0. Now squaring both sides. Squaring both sides. As soon as squaring both sides, this square and square root will cancel. So 3 will be only remaining. It will be a square divided by b square. Now bring the b this side. Since it is a divide, it will be multiplication. 3b square equal to a square c. This number is divisible by 3, therefore a square is divisible by 3. So implies 3 divides a square, implies 3 divides a. Now we have to we got for the a factor is 3. Now we are going to find the factor of b. Let a equal to, because this is a root 3, now we will write 3c for some integer, c. Now this will be equation number 1. Putting a equal to 3c in equation 1, that is a equal to 3c. Instead of a, it will be replaced by 3c. So 3b square equal to 3c whole square. Now 3 square, that it gives 9c square. It is cancelled by 3. So it is b square equal to 3 c square, because this is divisible by 3, therefore b square is also divisible by 3, because this divides by 3, divisible by 3, this also divisible by 3. So 3 divides b square, implies 3 divides b square, implies 3 divides b. Now we got the two common factor, thus 3 is common factor of a and b, which is contradiction to our assumption. Therefore root 3 is irrational number. Now example number 6. Show that 5 minus root 3 is irrational number. If it is the MCQ, you can write directly irrational number, because if you subtract from the rational number any irrational number, it will give the irrational number. But if we have to prove it now. because it's not MCQ. Example 6, that is 5 minus root 3. Same, if possible let 5 minus root 3 be a rational number. In simplest form. Simplest form means only the one is a common factor. Therefore, 5 minus root 3 is equal to a by b. B does not equal to 0. Now see, keep the this, take the 5 that side. So it will be minus root 3 equal to a divided by b, plus you will keep minus. Now make it rational number. So minus root 3 is equal to a divided by b minus 5 by 1. So you will minus root 3 is equal to, take the LCM b. So b divided by b, it will give 1 into a, that is a, minus this will be b, and if you divide b by 1, it will give b, the result will be b, and multiply with 5, it will be 5b. Now see, we cannot keep the negative sign this side, so take the multiply both side by negative. If you multiply both side by negative, so it will be, see, negative and it's negative. So here one negative, it will be a minus 5b divided by b. So we have multiplied both side by negative. So negative and negative, it will give positive. If you are one enough, you can write directly this, no need to show this. So it will be sign change. It will be minus a, minus into minus, it will be 5b divided by b. Always while writing, write the positive first. So root 3 equal to 5b minus a divided by b. See, now this is a rational number. So this was also rational number, but we know that the root 3 is not a rational number, it's an irrational number. So our contradiction is that is our which contradict our consideration, our assumption. So 5b a minus b is rational number. Rational number. So root 3, because this and this are equal, so this is rational, so this also rational, is rational. Is it root 3 rational number? Root 3 is not a rational number. So, but this contradict the fact that root 2 is irrational number. Therefore 5 minus root 3 is irrational number. Example number 7. Show that root 2 is a irrational number. Show that root 2 is a irrational number. If it is in a MCQ, it will be irrational number, because if you multiply the rational number, 3 is a rational number, 3 a rational number and the irrational number, always it will give the irrational number. Example 7. This is example 7. Prove that example 7 prove that 3 root 2 is a irrational number. Same. If possible, let 3 root 2 be rational number, rational number in simplest form. In simplest form. So there is only one is a common factor. 3 root 2 is equal to 8 divided by b. Keep only the root this side, take the rest number. So 3, take it that side. Now check the operation between 2 and root 2 and 3. What is the operation? Multiplication. So it will be divide. So root 2 equal to 8 divided by 2 into b. So it is a into, so it will be divide. So it is 3, not 2. So root 2 equal to 8 divided by 3b. So this is a rational number. 8 divided by 3b is a rational number. If it is a rational number, therefore, so this also rational number, because this and this are equal to, root 2 is rational. Is it root 2 rational number? Because this and this is also rational number, so it have to be rational number. But is it root 2 rational number? Root 2 is not a rational number, it's an irrational number. So, but this contradict the fact, contradict the fact that root 2 is irrational number. Therefore, 3 root 2 is irrational number.